Hello everyone. Um, I am trying to make a video to help you guys solve some of the volumetric and gravimetric questions. Like this particular video is just to show you how to solve the first question. This is mainly for those who's finding it a little bit difficult to solve these questions. These are the questions from the additional practice that I have uploaded into the week 3 lesson. Now, please take note that you are supposed to get to this point into trying these questions only after you have fully understood all the questions that we have discussed in the tutorial sessions. You should be able to completely understand how those questions are solved. So at different points of time, you should be able to try the questions by yourself without referring to anything and be able to arrive at the answer points that we have already discussed. So this is an additional practice. So by the time you get to these questions, you're expected to be able to solve at least 90% of it. One more reminder, please only watch this video once you have given it your full attempt, full try, and you have completely given up, not being able to arrive at the given answer. And the given answer for this particular question, I'm going to write it at the side here, is 0.67 mole per liter. I'm sorry, you got to forgive me for this really bad handwriting. I just got this tablet. I'm still getting used to writing on it using a stylus. Okay, right, let's get down straight to the question. Now, this is a volumetric question. This is the first question. It's a unique question because the dilution bit of it can get a little confusing if you don't pay attention to it. As usual, all the volumetric questions, there's general 3 steps that you need to address before you can go on solving it. The first one, I would say, you need to be able to ID key info. Now, I'll get to that in a bit. I'll show you what is key info. And second bit here, you should be able to understand the flow of information. Gosh, the handwriting is really bad. Understand flow of info. So I've mentioned this in class. Flow of info is referring to basically you trying to understand what they have practically done with the substances in this particular question. And then, of course, third is an optional requirement, which is equations, because very often equations are given unless the reaction is a rather simple reaction. This particular reaction is considered simple because it is a neutralization question. So general neutralization equation is governed by a single hydrogen ion reacting with a single hydroxyl ions to give you H2O. So in this particular example, they have given you the full equation. What I've written down here is an ionic equation. Both works if you understand what you're doing. Okay, let's get to it. I'm planning to keep it really, really short. Now, first step is to identify what's given in the question. So one of the major information, I'm going to circle it on the question itself, that it's sulfuric acid, and only 25 cm³ of this sample of acid. We obviously don't know what's the concentration. It's dropped by pipette onto a standard flask and made up 250 cm³, which means if I were to just give you a simple drawing of what basically has happened is that they've put a 25 cm³ of acid into this, so that's H2SO4 into this, and then they have topped it up with water to make up 250 cm³ of total solution. So it's worth taking note that out of the 250 cm³, whatever hydrogen ion that you're going to have are going to come from the sulfuric acid. That's the idea. So please remember that this bit here, the hydrogen ions from water is negligible because it's generally really small in amount. Then what has happened is they pulled out a 25 cm cube aliquot or sample, and that particular bit here, it's in the question, so the 25 cm cube here, that was titrated with a standard 0.1 mole sodium hydroxide solution and 33.5 cm cube solution is used. So this bit here, they have neutralized it with sodium hydroxide, concentration 0.1, and of course they have used 33.5 cm cube of it. Now, equation is given, so the thing that's worth taking note is 1 mole of sulfuric acid requires 2 mole of sodium hydroxide. Now, it's pretty clear that this is neutralization equation, but we know that each sulfuric acid is going to release 2 hydrogen ions. In this case, that's the reason it's the ratio of 2 to 1. Now, first step, always get the number of moles that's given to us. So I can convert this to number of mole. That's going to be my first step here. So my first step here is to get it to number of mole, and I'm having a bit of a hard time with this stylus. Okay. All right, it's not helping. Okay, all right. So let's do this. So number of mole N equals to 0.1, N equals to CV, just remember that, times 33.5 over 1,000, because the volume is given in centimeter cube, cm cube, and N equals to C. Molarity stands for, you can see that here, that's the liter. Okay, so the final answer, if you were to convert that, I've already pre-calculated this, so I don't have to be keying it right now. I'm supposed to make it fast. Okay, so the right answer here will be 3.35 times 10 to the power of negative 3 mole. Okay, so that's the number of mole from the sodium hydroxide that we've used. Now the idea is the number of mole will be of the sodium hydroxide should be half of the sulfuric acid. Why? Because again, take note here, there's 2, and the 2 only requires 1 sulfuric acid. So we technically, the amount of sulfuric acid that we require is only going to be half of this amount. So 3.35 times 10 to the power of negative 3 divided by 2. That's going to give us 1.675 times 10 to the power of negative 3. Okay, so moles. Now that's the number of mole of sulfuric acid that was based on this titration. And please take note, this titration only used 25 cm cube from this 250. Okay, so you need to remember that this is an aliquot. An aliquot means it's proportionately smaller. That means the proportion here is from 25 cm cube to 250. That's 10 times. So the number of mole in 250 cm cube, as this is in 25. So that's in 25. So that's times 10. Automatically, the answer is 1.675 times 10 to the power of 10 to the power of negative 2. Okay, so that's the number of mole in the original 250 cm cube. And yeah, this is the flow of information. It's important to take note that all of the hydrogens in this 250 cm cube came from the original 25 cm cube. So if I were to convert the concentration, because the question asked us the concentration of the original sample, and this is the original sample, I would just take note that this is, all of this is from the original sample. The concentration will be equal to number of mole over volume. So the volume here is 25 cm cube. Number of mole is 1.675 times 10 to the power of negative 2 over the volume been given is 25 cm cube, so we do have to change it to liter, so that's 0.00025. Okay, I think that would be wrong. 1, 2, 3, 1, 2, 3, 0.025. Sorry, cancel that. It's 0.025 cm cube, and that will give us a concentration of 0.67 mole per liter. Okay, right. We got that. First, apologies for this really messy writing. I hope to improve. I'm still getting used to this Wacom tablet, and this is obviously inspired by Khan's video. It's my plan to make these short little videos for you guys along the semester to help you revise some of the complex things that we may have to do in a certain speed in the tutorial sessions. So if you have any more questions, or if you have any particular question that you want to see me solving for you, you can drop me an email as usual. Alright, okay, signing off. This is Mr. Mohan. Enjoy your holidays. Bye-bye.